Hi students, in this video we are going to learn about circle theorems. Basically, there are 8 circle theorems which you need to understand to solve any kind of questions based upon circles. So I will explain to you step by step all these 8 circle theorems. Number 1, the first theorem is called as same segment theorem. Same segment theorem states that if we have an arc, in this case from A to B, arc AB, it subtends two angles on the circle. One is ACB, this angle, and second is ADB. So these two angles are from the arc AB on the same circle, so they are equal. So basically, angle ACB is equal to angle ADB. This is called same segment theorem. Second theorem is called as bow theorem, necktie bow theorem. Bow theorem states that from an arc, angle subtended on the circle, in this case ACB, and angle subtended on the center of the same circle AOB. They are connected. Basically, angle subtended at the center, in this case AOB, is twice the angle subtended at the circle. That means it is double the angle ACB. In other words, angle subtended at the circle is half the angle subtended at the center. So we call this as bow theorem. Same segment theorem. Angle subtended by an arc on the circle are equal, like in this case here and here, ACB and ADB. Bow theorem, angle at the center is double the angle at the circle. So two theorems are done. Move on to number 3. Third theorem is quite simple. If we have a diameter in a circle, diameter subtends always a right angle up on the circle or down on the circle. That's called as semicircle theorem. So this angle is always 90 degrees. Fourth theorem is quite simple. This is center of the circle and this one is radius of the circle. This theorem states that radius is always perpendicular. Radius is always perpendicular to tangent at the point of contact. So first theorem is same segment theorem. Angle by an arc on the circle are same always. Second is bow theorem. Angle at the center is double the angle at the circle. Third theorem is angle by the diameter in upper or lower semicircle. Half circle is always right angle, 90 degree. Fourth is radius is always perpendicular to tangent. Number 5. Fifth theorem is called as alternate segment theorem. This theorem states that angle subtended between tangent and the chord, in this case this is chord and this is tangent, is always equal to the opposite angle in the other side, in other segment. So this segment, this is smaller segment, minor segment, and angle between the chord, this chord, and this tangent, which is x in this case, is equal to angle in the opposite or the major segment, this angle. Likewise, this angle is equal to this angle. That's called as alternate segment theorem. Now again, same segment theorem is AB, arc AB or chord AB subtending two angles in the same segment. In this case, major segment, they are equal. Alternate segment, here angle X is in the minor segment here, and this angle X is in the major segment. So they are in the alternate segment, still they are equal. Number 6. If any quadrilateral have 4 vertices on the circle, all 4 vertices of a quadrilateral on the circle, in this case ABCD, that quadrilateral is called as cyclic quadrilateral. Now the theorem states that opposite angles of a cyclic quadrilateral are supplementary, means they add up to 180. Here A and C are opposite angles of this cyclic quadrilateral. They will add up to 180. Likewise, B and D. Number 7, radius chord theorem. This theorem states that a radius which is perpendicular to a chord in this case this is radius, a radius which is perpendicular to the chord will bisect the chord, means will divide the chord into equal half. This AM and MB are equal. Or you can say that if a radius bisect the chord, touch the chord at the midpoint, then it is always perpendicular to the chord. Other way. That's called radius chord theorem. Number 8, exterior point theorem. It states that if we have exterior point P, in this case, out of the circle, when we draw two tangents from this exterior point touching the circle at two different points, up and down, x and y. So the segment from P to x and P to y is equal. So in this case, Px is equal to Py. Means an exterior point is always at equidistant from the point of contact. This is exterior point theorem. Let's go fastly again. First theorem is same segment theorem. It states that angles in the same segment by an arc are equal. In this case, ACB and AGB are equal. Both theorem states that angle at the center is twice the angle at the circle, or angle at the circle is half the angle at the center. Third is angle by the diameter in the half circle, semicircle, either up or down, is always 90 degrees, right angle. Number 4, radius is always perpendicular to tangent. Number 5, angle in the minor segment of a chord with a tangent is always equal to angle in the major segment. So x equal, likewise y equal, because they are in the opposite or alternate segment, not in the same segment. Sixth theorem states that if a quadrilateral with 4 vertices on the circle is called as cyclic quadrilateral, opposite angles of a cyclic quadrilateral are supplementary, they add up to 180. That's the reason B plus D is 180, A plus C is 180. Number 7, radius if perpendicular to chord will bisect the chord into equal pieces, or if it bisects the chord, that means it must be perpendicular to the chord radius. Last theorem, 8th theorem, is exterior point theorem. States that an exterior point is always equidistant from the point of contact to the circle. That means segment PX and PY is always equal. So after understanding all these 8 theorems and keeping in mind, we can solve questions which are from the exam. Example, one of the example is here, exam style question. Let's try to solve this question. In this question, he's asking to find the variable angles like x, y and w. So first of all, we should focus this quadrilateral, which is AB, BD, DE and EA. This quadrilateral A, B, D, E is a cyclic quadrilateral. That means opposite angle must add up to 180, 140 and W, these are opposite angles, they will add up to 180. That means W is equal to 180 minus 140, which is equal to 40 degrees. W is done. We find out W, it is 40 degrees. Likewise, if you focus this chord or the arc, if you focus this arc DC or chord CD, whatever, chord CD, DC or arc DC, CD, you can see that this arc subtends an angle at the circle which is Y, this angle. In the same arc, subtends another angle on the circle which is this one. So angle DAB and angle DBA are from the same arc, but the first theorem, same segment theorem, this angle must be Y, right? So this angle is Y because of same segment theorem. Theorem number 1. Now further we can see that this is a straight line, ABE is a straight line, so this is 180 degrees angle. From here we can find value of Y easily. We found that W plus Y plus 95, These three angles are straight angles, add up to 180 degrees. These are straight angles. Because W is 40, we can plug in here. We get here 40 plus Y plus 95 is equal to 180. That means Y is equal to 180 minus 95 plus 40 is 135. 180 minus 135 degrees will be 45 degrees. So we got value of y. Y is 45 degrees. W was 40 degrees. Now the third angle left out is x. Now we can find x again by cyclic quadrilateral theorem. Let's change the color here. Again, by applying cyclic quadrilateral theorem in quadrilateral A, B, C, D, and A. So quadrilateral, I write here for you, quadrilateral A, B, C, D. Again, this is another cyclic quadrilateral. If it is cyclic quadrilateral, 4 vertices on the circle, opposite angles must be supplementary. That means x and w plus y, x are supplementary. Means x plus w plus y, they are opposite, they will add up to 180 degrees. Target was to find x. We know w and y already. W angle is 40, we found out, and y we got 45. W 40, y is 45, that's equal to 180. So x will be equal to 180 minus 85. 180 minus 85 is 95 degrees. So x is 95. So we got x already. So basically what we have used two theorems, one same segment, and one theorem number 1 and one cyclic quadrilateral, theorem number 6. So theorem number 1 and 6 we used continuously to solve to get the values of x, y, and w unknown angles. I hope you guys understand. Take care.